My voice is clear or not?
Yes, sir.
Okay. So I have completed parallel with cell voltage V0. Okay. Means I have not completed that. Okay. Okay. So I'll write down the question. The plates of parallel plate capacitor the plates of parallel plate capacitor have an area of 90 centimeter square each and separated by 2.5 mm apart. The capacitor is charged the capacitor is charged by connecting it to a battery of 400 volt supply. Calculate number 1 electrostatic energy stored in the capacitor. Second, energy density of the capacitor. So here we have given that in the question it has given that the parallel plate capacitor have area 90 centimeter square and D is equal to 2.5 and charged it by so this is the parallel plate capacitor and this is connected by a battery of 400 volts. This has some capacitance C. Okay. And if nothing is given, consider air is filled in between the plates. Okay. So here air is filled. So so now first we will calculate C. And area is given as 90 centimeter square. And I will convert this into meter square. It will become okay meter square. And D is given as 2.5 mm. This will become 2.5 into 10 to the power minus 3 meter. So I can write here for the, if I want to find the capacitance C, this will become epsilon naught A divided by D. Epsilon naught is 8.85 into 10 to the
8.85
power
10 raised to minus 12.
minus 12. Very good. Area is 90 into
19 10 raised to minus 4.
10 to the power minus
Minus 4.
And D is
Distance is 2.5 and 10 raised to minus 3.
Very good. When you will calculate this, you will get the answer 8.85. Not 8.85. Okay, I am calculating. Okay. So, so this is 10 to the power 12 and minus 4. So this will become 16 and this will become 10 to the power minus 13, and this we have to calculate. This will become, you can also calculate this. Okay. So this will become 8.85 into 36 into 36. This will become 8.85 into 36 into 10 to the power minus 13 farad. And you can multiply this now. Can you do this, Harsh? Okay, you can do this.
Yes,
Okay?
sir. Yes, sir. Yes, sir.
Okay. Now I am moving forward. Okay. So this is very easy calculation. You can do it by yourself. So we have calculated the capacitance. We have calculated the capacitance. Okay, and they are asking how much electrostatic energy is stored. How much electrostatic energy is stored? We have the formula of electrostatic energy as we have three formulas: Q square by 2C, half CV square.
Yes, sir. For electrostatic energy, half CV square.
Half QV.
Yes, sir.
We have three formulas. Now,
yes, sir.
We do not have charge here. We do not
yes,
have
sir.
charge here. We do not have charge. We have only capacitance and voltage. So we will use this formula.
Half CV square. Yes, sir.
I am not using this formula because we
don't have charge.
We do not have charge. So we will use this formula. U is equal to half CV square. CV square. So half C is given by 8.85 into 36 into 10 to the power minus 13, and V square is 400 square. This is V na? This is V. This is voltage V, 400 square. 400 square, and we will get the electrostatic energy as U is equal to 8.85 into 72 into 10 to the power minus 13 joule. We will get U this. Okay. So this is the answer. We can multiply this and get the answer. This is very simple. And why I have used this formula? Because we have capacitance and we have potential. Oh, sorry, not potential. We have voltage. Okay. Second part is we have to calculate the energy density.
Yes, sir.
So energy density is represented by small u, and small u is half epsilon 0 into electric field square. We
Yes,
have half, we have epsilon 0, but we do not have electric field. We do not have electric field. So we know that the electric field has a formula sigma by epsilon naught.
Sigma by epsilon naught.
But we have epsilon naught, but we do not have
don't
sigma.
have sigma.
So sigma is Q, means charge upon area. We have area is equal to 90. So 90 centimeter square we have area, but we do not have charge. Okay, we do not have charge. We will calculate the charge anyhow. We have to calculate the charge. So see how I am calculating the charge. I am calculating the, I can write U is equal to half QV. If I am using this formula, I can write U is equal to half QV.
Yes, sir. Yes, sir.
So, and U is given to us. U is known. U is 8.85 into
8.85 10 raised to.
Okay. 8.85 into 72 into 10 to the power minus 13, and this will become
13.
equal to half. We have to divide Q, and we have this 400.
400.
From
So 2
here,
will shift up and then 4 will come down.
okay, we can do the calculation. Okay, calculation
Yes,
is not. So the value of Q will become 1 minute. Okay, here the value of U is I think you will get the value of Q 8.85 into 72 into 10 to the power minus 13. Okay, Coulomb. Okay.
Yes, sir.
I am calculating this. So this will become 10 to the power 4 and 8.85 is here. Okay, and this will become 18 and this will become 16. 18 into 16 and 10 to the power 4 into 10 to the power 30. So we become 10 to the power minus 8 here. Ten to the power minus 8. Minus 8, and this will be 18 into 16. Okay. 18 into 16. So this will become 288. So when you will calculate this, this will become into 288 type. You can check the calculations. Okay. So here we will get the value of charge. So we have to put the energy here. 8.85 into 288 into 10 to the power 288 into 10 to the power minus 8. Minus 8, and Q is come out to be this.
Yes, sir.
And from this Q I can calculate sigma. I can calculate sigma is equal to Q by A.
Sigma, yeah, Q.
Sigma is equal to Q by A, and Q is 8.85 into 72 into 10 to the power minus 13, and area is 90 centimeter square. When you will calculate, you will get the value of sigma this. Okay, the value of sigma will be 8.85 into 72 divided by 90, and this will become 10 to the power minus 9. So we have sigma.
Yes, sir.
And if we have sigma, then we can calculate the electric field if I divide this by epsilon naught.
Yes, sir.
So electric field is equal to sigma by epsilon naught. So sigma is this 8.85 into 72 into 10 to the power minus 9 divided by 90, and also we have to put the value of this 8.85 into 10 to the power minus 12, and we will get the value of electric field as 800 volt per meter, or the other unit of electric field is newton per coulomb.
Yes, sir.
So now we have electric field, so I can calculate the small u half epsilon naught into E square. We have half, we have epsilon naught, 10 to the power minus 12, and E square means 800 square. So you can get this answer in joule per
12.
meter cube. Okay, you can calculate this. So in this way we can find the, here the my motive is to tell you how to apply the formula,
Yes,
not
sir.
to not the calculations. Okay, calculation will be easy when this question will appear in your exam. You can solve, but you should think how you will apply the formula, which formula you should use. Here we have
Yes, sir.
use this formula because we have capacitance and we have voltage, and here we have used this formula. Here we have
Yes, sir.
used this formula because we want to calculate the value of charge, and we know that the energy density is half epsilon naught c square. We have epsilon naught, but we do not have E. So for E we have calculated first sigma, and for sigma we have calculated charge. So means in the numerical you have to relate the things. Okay, in the numericals you have to relate the things. So please note it down.
Yes, sir.
Always convert the unit into the SI unit.
Yes, sir.
Actually, theory and numericals are different types of things. They are of two different types of things. In theory, we have to learn the things, but in
Yes,
numerical, we have to apply the things, apply the concept.
yes, sir. Sir, can you scroll down? Second scroll down. Yes, sir. Yes, sir. That's it. That's it.
Okay, fine.
Yes, yes, sir.
Fine.
Yes, sir. Second scroll down.
Okay, Harsh, you can check the calculations by
Yes, sir.
yourself.
I'll
Okay.
check the calculation, sir.
But the main thing in the numerical is that na, how to apply the formula, which we have lots of formulas and we have to apply those formulas correctly.
Yes,
Means
sir. Sir, the values which come in formula, we should apply that formula.
yeah. We have to solve our question.
Yes, sir.
So accordingly, we will apply the formula.
Done, sir.
Okay, done.
So just
This
yeah.
energy
So just
density.
okay, yeah. Just a minute, sir. Just a minute.
Okay, you can take your time, no problem.
Second scroll down, sir.
Fine.
Yes, sir.
So in this way, you can solve the numericals.
Sir, yes, sir. Can I scroll down? Done, sir.
When the battery is connected, charge voltage. Okay. Now we have to we will discuss now. So we will discuss some cases of capacitors when the battery is connected or battery is disconnected. So write this in the form of note. Number one is parallel plate capacitor. Parallel plate.
So just a minute, just a minute.
Okay, no problem.
Yes, sir. You can continue, sir.
Okay, parallel plate capacitor.
Parallel plate capacitor.
with air.
With air.
Air.
Yes, sir.
Hawa.
Yes, sir.
Between
Between
plates and plates. And capacitor connected with capacitor connected with battery of voltage V naught, and this battery remains connected. So you have a capacitor like this. Okay, you have a capacitor like this, and you have connected this capacitor with battery of voltage V naught. This is the voltage of battery,
yes, sir.
or you can say this is the voltage across the capacitor. And we know that this is positive, this is negative. So this plate will be positively charged and this plate will be negatively charged. Okay.
Negatively charged.
And remember one thing. I have told you this thing earlier also, but I am telling this again. Voltage, or you can say potential difference, PD, I am writing in short form, between plates will remain same, will remain same, will remain same when the battery remains connected. When the battery remains connected. So just wait for a minute. So I have told you now, here is this is the power source, and this power source is connected. This power source is connected.
Yes, sir.
So we can say the voltage will remain same across the when the battery remains connected.
Yes, sir.
So one of the most important point. So Harsh, this is the
Yes, sir.
condition. This is the condition, and we know that the battery is connected. And now we will accordingly find the charge, potential,
Yes, sir.
and all that. So first thing is, what will be the capacitance? what will be the capacitance in this condition?
Yes, sir.
So here, if nothing is given, so you can consider here air is present only. Air is present. Here the air is given now in between the plates.
Yes, sir.
So what is the formula for capacitance? C is equal to, when air is placed, epsilon naught 0 A divided by D. Okay. So capacitance will become then this. Okay. So please note it down.
Yes, sir.
This is the simplest case.
The first one. Yes, sir. You can continue, sir.
हाँ, एक मिनट रुको. If I want, अगर मुझे voltage निकालना है, if I want to find the voltage across capacitor. So Harsh, please tell me what is the voltage across capacitor? V naught.
Voltage.
V naught,
So
na?
V not V, yes, sir, V not.
V naught, because
Yes,
the
sir.
battery is connected, so voltage is like this.
Yes, sir.
Okay. Now third thing is charge stored. Charge stored in capacitor. So what will be the charge? Charge, we know that charge is equal to CV. Charge is equal to capacitance into voltage. Okay. And see here, charge Q, C is epsilon naught A divided by D, and V is V naught. So this is
Yes,
the
sir.
charge. This is the charge. Simply you can say. This is the charge.
Okay.
And fourth thing is, if you want to calculate the energy, so simply you can write for energy stored in the capacitor. Energy stored in the capacitor, and energy stored is represented by capital U, and capital U, you have three formulas. I am using one of the formulas, like half C V square. So this will become half C naught, oh sorry, C into V naught square.
C V not square.
This is the simplest case.
Yes, sir.
And I want to change one thing here. ये कहाँ गया? Okay. So write here capacitance C naught, because we represent C naught as capacitance when air is present. Okay. So write here, and I am writing charge Q naught. Q is equal to CV. So I can write
Yes, sir.
from here charge. This is the charge in the plates when air is filled. So this will become C naught into V naught. So C naught is this and V naught is this. This is Q naught. So Q naught is the charge in air.
Yes, sir.
In air means when, okay, energy stored in the capacitor is, I am representing this with this, and this will become this. So naught means this is 0. If I am, this is the U naught represents the energy stored in between the plates of capacitor when there is air in between the plates of capacitor. Okay. So please note it down. This is very simple. You have you completed this?
Yes, sir.
Okay, very good. Then please note it down for me.
So can you scroll to the fourth one? Yes, sir.
This chapter is just about to complete.
Yes, sir.
Then we
No,
have
sir.
very easy chapter.
Current
Current
electricity.
current electricity. We will play with current.
Yes, sir. It's not that easy, sir.
It is easy. You will see.
Sir, I did that chapter and it's not that easy. Yeah,
Actually,
it's fine.
no. According to me, that chapter is uh, 2 times easier.
The easiest chapter is electric field and charges. Yeah, the first one.
No. That chapter is very tough. Matlab, no, not for me. For the students, I can say that chapter is tough because in the electric field and charges, there is a use of vector laws and vector addition. So we
There
वहाँ पे
is. They didn't teach us in school. That's how.
okay, no problem. Okay. So when dielectric slab fully inserted between the plates and battery remains connected. So we know that when the battery remains connected, voltage remains same. No
Yes,
matter
sir.
what you are filling,
Yes.
in between the plates. So this time the capacitor is connected with the battery. Battery, same battery. This battery having the voltage V0 and this battery is again having the voltage V.
You know,
This is voltage. Voltage is also called potential difference.
potential difference.
And this time the one thing is changed. We have filled the dielectric fully in between the plates. Dielectric is filled.
Yes, sir.
This is dielectric. And K is dielectric constant of this dielectric. Dielectric constant.
Constant.
Now, one by one we will calculate. One by one we will calculate the capacitance, voltage, and all that. So, if I want to calculate the capacitance, so I will represent Cm when some dielectric or some medium is filled. Please remember this. So, what will be the capacitance this time? Cm equal to K times of C naught. We have this formula. The capacitance will become K times now.
Yes, sir.
Now the capacitance Cm is the capacitance when this dielectric. I have told you this. Cm is the capacitance when dielectric is filled. Okay. Now battery remains connected and dielectric is filled, but due to this dielectric, the capacitance becomes this. The capacitance becomes K times of C naught. So K for C naught we have epsilon naught A divided by D. So from and K is always greater than 1, not always means here I am taking K is greater than 1. K is greater than or equal to 1. Like for air, the K is 1. For water, I think it is 80. So leave that. So from here, you can say that capacitance will increase or decrease. This K is greater than 1. So capacitance will increase because this K is greater than 1 and you are multiplying this term with something which is greater than 1. So this term will be greater, means will increase. So you can say in this case capacitance increases. Capacitance will increase. Second point, now voltage. Voltage across capacitor. So Harsh, what is the voltage? We know that the battery is connected. Very good. Voltage is V naught.
Yes, sir.
This time also. Because the battery is connected. Third is charge stored. So I can say this will remain same.
Yes, sir.
Remains same. Charge stored in the capacitor. Charge stored in the capacitor. So charge, for the charge we have formula capacitance into this. So for Q I will write Qm. This time means Qm is charge when medium is filled. So Qm is equal to Cm into Vm.
Yes, sir.
Okay. So Qm I want to calculate. Cm is K times of C naught. And
yes.
Vm is Vm. This is Vm actually. This is Vm. Vm is equal to V naught.
Yes, sir.
So charge Qm is equal to K and C naught into V naught is equal to Q naught. Here you can see that Q naught is equal to C naught V naught means here what can you say about the charge? Charge will increase or decrease? Charge will increase. You can see either you are here, okay, and someone is giving you the charge again and again. So charge will increase on you or decrease? Harsh, are you getting?
Yes, sir. Yes, sir. Yes, sir. Yes.
Have you
Can you
heard what I have said?
Sir, actually I was lying. Can you please repeat
Okay.
from charge will increase?
Okay. I am saying this is you.
Yes, sir.
And someone means here is a battery. Battery is someone.
Yes, sir.
And this battery is giving you charge again and again. So charge on you will increase or decrease?
Increase.
Increase. You can this I am doing with the help of formulas, but logically if you think, then charge will increase.
Yes,
Means
sir,
the
it will increase.
means the the purpose of battery is to give the charge to the capacitor. What is the use of battery? Why we are using the battery here?
To
Why
give
we are
charges, sir.
why we are purchasing battery from the market and connecting here? Why we are wasting? Why we are wasting our money? Because we want to charge the capacitor. Means we want that battery should give the charge to the capacitor, so that we can use the capacitor in some applications. Okay, so charge will remain same. So sorry, not charge will increase. So if I want to know that energy is stored, this you can tell easily. Suppose this is you and this is the battery, and this battery is giving you the energy again and again. So energy on you will
Yes, sir.
increase or decrease?
Increase, sir.
Increase. You can see, but I will prove this with the help of formula. Logically, so it is correct, but I want to find the energy. So write Cm into Vm square, half Cv square, na? So
Yes, sir.
M is for medium, means dielectric is placed. So value of Cm is K times of C naught, and Vm we have, Vm is same, na? Vm is equal to V naught square. So you can see here the energy will become this. So from here also you can say that Um is the energy when dielectric is filled. K times of U naught. You can say from here energy will increase. Energy stored will increase. Okay, fine. Okay, Harsh, please note it down.
Yes, sir.
Now, there is there is a case which is very interesting. Now I am removing this battery. Now I am removing this battery, and now we will see what will happen if I remove the battery. Harsh,
Yes, sir.
have you seen the movie Thor 4?
Yes, sir. Love and thunder, right?
Have you seen that movie?
Yes, sir. I am.
Very good. I have also seen.
Second problem.
Yeah. So have you seen the charges and electric field there?
Yes, sir. Second problem. Done, sir.
This also this part.
So just one last line.
You can get the questions in your exam from here.
Yes, sir. Done, sir.
Now what I am doing, I am just removing this battery. So Harsh, let me explain you. If this is the capacitor,
Yes,
and
sir.
here I have a battery, and now air is in here. Okay. So here this battery V0. Now I have removed this battery. So if I will remove this battery, suppose this is you and someone is giving you the charge again and again. Now, now he or she is no more. Means here. Okay.
Yes, sir.
Now he or she is not giving the charge to you. So charge will remain same.
Yes, sir. Constant.
Charge will remain same because now there is no battery to give the charge to the
Give the charge.
capacitor, but charge will remain same. And what about the energy?
Energy.
And someone is giving you the energy again and again. Now
Energy will
he or
increase.
why the energy will increase? Listen carefully. This is you
Yes, sir.
and this is you. Please, this is very important point. And this is someone else. This can be male or female. This is giving you the energy. Take the energy. And now someone has killed this.
Yes, sir.
So what will be the energy? Energy will increase, decrease, or remain same.
Sir, just a minute, sir. Yes, sir, it will remain constant, sir.
So have you seen this? Where have you seen this?
No, I was my network was
Constant, na? Constant, yeah.
Yeah.
Constant.
Yeah.
Constant. Someone is giving energy, and now he is no more.
It's
He is
not
no
there,
more
so
the
it's
energy.
constant, right? Energy is still there.
Okay. Let's see. Now this is the case when the air is in between. Now what
Yes,
I
sir.
have done, I will explain you each and every term. I am just now I have inserted the dielectric and now remove this battery. Now removed the battery. Remove the battery. So
Yes, sir.
in this case, charge will remain same. But the energy will decrease. Why the energy will decrease? Due to this dielectric.
The dielectric.
Due to this dielectric, we have discussed that the electric field will decrease due to the dielectric. What will be the electric field? Electric field will become E naught by K. If electric field
Yes,
is
sir.
decreases, means the energy decreases. So, okay, no problem. Fine. So now I am energy can neither be created
nor be destroyed.
So, okay. Third is a dielectric slab is inserted fully and battery disconnected. Have you seen, is this visible to you, this thing?
Yes, sir.
And battery disconnected.
Yes, sir.
Now we will calculate all the terms. What will happen to the capacitance, what will happen to the voltage, what will happen to the charge, what will happen to the energy. And we will do this with the help of formulas. Here is the capacitor. Now there is no battery here. Battery is removed and
Yes, sir.
this is filled with some dielectric
Yes.
fully. This capacitor is filled some dielectric fully, and the dielectric constant is K of this dielectric. Dielectric constant is K of this dielectric. Now no battery. So what happened if there is no battery? Earlier there was battery. The battery
Yes,
is giving the charge. Now suddenly you remove the battery. So charge will remain same. In this case, you will say.
Yes, sir. Charge will remain same because the battery is removed.
Inside
the capacitor.
On removing the battery, you can say charge will remain
same.
If battery disconnected, then you can say charge will remain
same
in the capacitor. Okay. Charge will
yes, sir.
Means charge. If I want to calculate number one, capacitance. So what about the capacitance? You have filled the dielectric, and
yes, sir.
you have Cm is equal to K times of C naught.
K times of C naught.
And K is greater than 1, so capacitance will increase. Capacitance will
increase.
Okay. This formula will never change whether you are connecting with battery or disconnecting the battery.
Yes,
so
sir.
Another term is voltage. If I want to calculate the voltage means voltage in this situation, Vm.
Okay,
So
Vm.
voltage is equal to charge divided by capacitance, and we know that charge remains same.
Yes, sir.
Charge is same earlier. The
same.
Charge
Capacitance increases. KCO.
Capacitance
yes, sir. KCO. Yeah.
So you can say Q naught by C naught is equal to V naught.
V naught
divided by K.
Okay.
So here you can say Vm is equal to V naught by K, and K is greater than 1. So the voltage will decrease from here.
Decrease. Yes, sir.
voltage, or you can say potential difference across the capacitor, voltage or potential difference across capacitor will decrease. You can see this. Vm is the, I am writing here, Vm is the voltage, okay, when dielectric field and battery removed. This is Vm. So means, okay, ठीक है, voltage. Okay. Now charge. What about the charge? Will remain same.
Yes, sir.
We know remains same, and the value of charge is equal to, this time the charge is Q naught. Fourth thing is, if I want to calculate the energy stored. So, अरे क्या हो रहा है? Energy stored. So energy stored means I want to calculate energy stored, Um. So we know that U is equal to half CV square. We will use this formula. So Um will be half capacitance in medium into potential in medium square. So we have half. Cm is K times of C naught. And what is the value of Vm? Vm is V naught by K square. So from here I can write K times of half C naught V naught square. Not K times means divided by K hoga. Harsh, what are you doing?
Sir, I was drinking tea, sir.
You're drinking tea, but okay. So here will be,
like I have headache, so that's what, sir. Sorry.
Okay. No problem. You can eat also. You can watch the movie also. It's your choice. And So here, this is
Yes, sir.
I can write here U naught divided by K. So here K is greater than 1. K is greater than 1 means this will increase or decrease. Energy stored will decrease.
Decrease. K is greater than 1.
Energy stored will decrease. We have discussed this earlier also.
Yes, sir.
Decreases. Okay. So energy stored will decrease. Now you can note it down. From here, na?
Yes, sir. Third case.
I am coming in 1 or 2 minutes.
Second scroll down.
You can note now. Are you writing, Harsh?
Yes, sir. Yes, sir.
Okay. Harsh, have you visited New Delhi?
No, sir.
You are from India.
Yes, sir. I'm from Pune, sir.
You are from Pune.
Yes.
Pune, okay. Please note it down.
Second scroll down.
Third point?
Yes. No, sir. It was second one only, but it was like. Yes, sir. That's it. That's it. Thank you, sir.
After this, we have series and and parallel
Parallel.
combination of
Sir.
capacitors.
Yes, sir. Second scroll to the fourth one.
Okay. Please remember, UM is the energy stored
Energy stored in a
dielectric is
capacitor. Yes.
when dielectric is filled.
Filled. Yes. Sir. Second scroll down. Done, sir.
So now we'll have series and parallel combination.
Yes, sir. It is easy, sir. For capacitance,
Very
series is
easy.
1 by C1 plus 1 by C2 plus 1 by C3. Parallel is C1 plus C2 plus
Very good, very good. Okay, series and parallel combination of capacitance. You are a very good student. Capacitors. Okay, so before this, I will tell you how to divide charge and how to divide voltage in the
Yes,
wires.
sir. Okay.
So let's see. So first we will study about the division of charge. Division of charge. So suppose okay, let's see here. Let's see here. This is the wire,
Yes, sir.
and in this wire, charge is flowing.
Yes, sir.
If I bend this wire like this,
Yes, sir.
will charge change?
No, sir.
Very good. But if I connect this wire, from here to another wire, charge will
Yes,
divide
sir.
or not? Charge will divide,
Yes,
no?
sir. It will. It will.
It will divide. So like this, we have the wire. If I am having a wire,
Junction rule of
yeah,
Kirchhoff's.
junction rule. If the wire is same, if there is no
Yes,
change
sir.
in wire, then charge will remain same. Always. Charge will remain same. If the wire is like this, then also the charge will same. Then also the charge will same. But
Yeah. Same.
this time I have this wire, and now there are 3 branches of this wire. So if charge here is Q1, then if Q1 is charge, Q1 charge is flowing in the wire, Q charge is flowing in this wire. So at this junction, you are moving from here to here, the wire is same. Now this is different wire, this is different wire, this is different wire. So here there will be different charge.
Yes, sir. Q1, Q2.
I am representing it with Q1, Q2 and Q3, and you can see this charge Q is dividing like this, so I can write
Q1 plus Q2 plus Q3.
simply.
Yes,
I can
sir.
write. If suppose if capacitors are connected like this, and
Yes, sir.
then also the wire will remain same, na? You have
Yes, sir.
connected the capacitor on the same wire. The
Yes, sir.
wire is same, the charge will be same.
Yes, sir.
Means you
1 by
can
Q
say,
plus 1 by Q plus 1 by Q.
yeah, that is fine. But you can say charge across every capacitor will remain same.
Remain
Suppose
same.
this C1, this is C2, this is C3, this is C4. So you can say charge across every capacitor, or it is better to write charge stored is same for each capacitor. Now here is a charge, and this wire, from this wire I have connected two capacitors like this.
Yes, sir.
This
Sir,
is
charge will
Q1.
be different, sir,
Yeah.
because
Charge
parallel
will,
and series connection is there.
yeah. You can see here, if charge Q is flowing here, means the
Yes,
wire
sir.
is same, charge is same. From this
So
point, this
it
wire
will
is
be Q1 and
different. This
Q2.
wire
Yeah.
here, charge Q1 will
Q1
flow.
and the other side will be Q2.
Here again Q1, or here charge Q2 will flow, and
Yes, sir.
here also charge Q2, and here charge Q1,
Q1.
and here charge Q2. So from
Yes, sir.
here you can write Q is equal to Q1 plus Q2, because charge is dividing from this point. Okay?
Yes, sir.
Please note it down.
Yes, sir.
And Q is charge.
Yes, sir.
Q is charge. Charge flowing, you can say.
Sir, can you scroll down?
So here you can write charge divides due to branching.
Yes, sir.
Due to branching. Three branches are there.
Sir, can you
Charge
scroll
will
down?
if the wire is same,
Charge will
then
be same.
the charge is same.
Yes, sir.
Whether the capacitors are there on the wire, whether the resistors are there on the wire,
Yes, sir.
charge will remain same. But the story of voltage or potential is something different.
Sir, done, sir.
Something different. Okay. So now second is division of voltage. Now we will see how the voltage will change due to branching and all that.
Yes, sir.
Division of voltage. Now see here, I am having a wire like this. So at this point, at this point, at this point, at this point, this is point A, this is point B, this is point C, this is point D. So Potential at A is equal to potential at B is equal to potential at C is equal to potential at D.
D.
Okay?
Yes,
This
sir.
is the potential. Potential at A, potential at B,
Equal at
potential
B.
at C is equal to potential at D. Now, this is a point, this is a point, this is a point. This is point A, this is point B, this is point C. Now move like this. If there is no capacitor or resistor, then the potential at A is equal to potential at B
Potential
is
at
equal
B
to
is equal to
potential
potential
at
at
C.
C.
If there is no capacitor or the resistor in the path of the wire, then the potential will always remain same.
Same.
Okay. Because these are wires, and
Yes,
wires are conductor, and we know that the surface of a conductor is equipotential.
Yes, sir.
So if the potential is like this, so you can say that here is, if the potential here is B, here will also be, here the potential will also be, here the potential is also be, here is
potential is
means
equal.
potential will not affected by branching. It
Yes,
will
sir.
only affected by the resistor or
Resistors,
capacitor.
capacitors. Yes.
So I am writing here divides due to capacitor
Capacitor or resistor.
or resistor in the path.
Yes,
or
sir.
resistor. Then write like and now see here. Suppose this is a point A.
Yes, sir.
And this is a point B.
Yes, sir.
And this is the capacitor C1. So at this point A, the potential is A.
Yes, sir.
And
VA.
at this point also potential is
it is
A.
VA.
VA. Yeah. And when you will cross this, the potential, there is a drop in the potential. There is a
Yes, sir.
drop in the potential because this device will take some potential.
Charge. Yeah, take some potential.
Or you can say there will be some potential drop. So here now the potential will be VB.
Yes, sir.
Here is also the potential is VB.
VB.
And VA minus VB
is equal to
potential difference across C1.
Yes, sir.
Potential difference across capacitor C1, or this is also known as voltage across C1.
Yes, sir.
Voltage across
C1.
This is point A, this is point B, this is point C.
Sir, done, sir.
Wait for 1 minute.
Okay.
Okay, Harsh, let's see. Here is VA. Here also is VA. But
Yes,
when you
sir.
cross this,
VB.
when you here is VB, here is VB. When you cross this,
VC.
VC and here is VC.
VB.
So
So
if I
potential
want
difference
to,
across.
yeah, if I want to calculate, I am writing now V1 is equal to, here is, this is C1, this is C2. I am writing V1 as potential difference or voltage across C1. What is the value of V1? VA minus VB.
Yes, sir.
And what is the value of V2? Potential across C2.
VB minus VC.
Very good. Now last case. Suppose the combination is like this. Suppose the combination is like this. Is this parallel combination or series combination?
Parallel, sir.
Okay. Now why this combination is parallel, we will see. We know that you know that in a parallel combination the voltage is same. Now we will see whether this is a parallel voltage is same or not. Why this is called as parallel combination? Okay, okay, fine. So I have told you, take this point as A, this is point B. So if you are moving from here to here and from here to here, if you are moving in this direction, here what is the potential here? VA. Here is potential VA, here
Yes,
is
sir.
potential VA, and here also, because there is no capacitor or resistor in the path, here is potential VA. So what is the potential at here? VA.
VA.
So here also the potential is VA.
It will be VA. And potential
Here,
on the cross side will be VB.
and now you are moving from here to here. So
Sir,
here
that's
is
VA, sir. Sir,
what?
that's VA.
Oh, sorry.
That's
Okay,
VA.
okay. I got it. Got it. Here is VA.
Yes, sir.
Why the potential is VA? Because there is no resistor or capacitor
No
in the
resistor or
path.
capacitor. Yes, sir.
In the path. So here is potential VB. So here also, accordingly, the potential is VB. Here also the potential is VB. Now, if the capacitance of the capacitor, this have capacitance C1, this is capacitance C2. So if I want to calculate V1 is the voltage across
Voltage
C1.
was across capacitor 1. Should it be VA minus VB?
Yeah, voltage across
capacitor 1.
C1 equal to VA minus VB.
Yes,
Similarly,
sir.
if I want to calculate V2 is same again.
Yes, sir.
VA minus VB. So see here, voltage across V1 is equal to voltage across V2. That's why we say these types of combination as parallel combination.
Parallel.
So okay, please note it down.
So done, sir.
So and this types of combination is known as series combination. We will study this in detail in the next class.
Yes, sir.
This is series because charge is flowing. Charge flowing is same. So
Yes,
have you written already?
Yes, sir. All of this I have written.
Okay, now Harsh, please revise your notes, and that's all for today. Thank you.